not connecting that things with the internet, then what is happening? This is just M2M portions up to this. Okay, up to this, this is only M2M portions. So this portion is M2M portions. So sensor is collecting the data, locally processed and locally stored, and we can see what is the temperature of our home. But when we are connecting that things with the internet through protocols like MQTT protocols, constrained application protocols, or many protocols are there for constrained devices. So if you are connecting with the internet and if you are storing the data onto the cloud, so this portion, these portions is nothing but this portion is our IoT portions, and these are the main portions, because we want to control the stuffs remotely, we want to automate our daily life. Okay, so if we will control the data, if we will store the data onto the cloud, then and only then we can do all these things. Now we can monitor the temperature from anywhere, not from our home, but from outside also. We can monitor what is the temperature of our home. If it is connected in institute, then we can say what is the temperature of our Parul Polytechnic Institute. Okay, so means we can monitor everything if it is connected with the internet, if the data are stored onto the cloud. Okay, like smart parking example. So there are many applications areas in cities, in environment, in water. There are many applications areas, and this 2 hours time is very limited time, so we cannot cover all these things. Okay, smart parking system, smart lighting, waste management. Okay, tracking any devices in agriculture, smart agriculture. If you want to track the animals, you can animals. If you want to observe your conditions, ambient conditions, means what is the pulse rate of the patients, what is the ECG of the patients, what is the oxygen level of the patients. You can monitor everything if you are connecting the sensor with the internet. Okay, so please see this smart small video, and then we will start the interfacing through one simulations, means how we can interface our Arduino with one sensors, and how we can practically executes, or how we can attach the sensors with the microcontroller. So that part we will see after this video. So please see this video.
4 years ago, we started to wonder. 4 years ago, we started to wonder, what would shopping look like if you could walk into a store, grab what you want, and just go? What if we could weave the most advanced machine learning, computer vision, and AI into the very fabric of a store, so you never have to wait in line? No lines, no checkouts, no registers. Welcome to Amazon Go. Use the Amazon Go app to enter. Then put away your phone and start shopping. It's really that simple. Take whatever you like. Anything you pick up is automatically added to your virtual cart. If you change your mind about that cupcake, just put it back. Our technology will update your virtual cart automatically. So, how does it work? We used computer vision, deep learning algorithms, and sensor fusion, much like you'd find in self-driving cars. We call it Just Walk Out technology. Once you've got everything you want, you can just go. When you leave, our Just Walk Out technology adds up your virtual cart and charges your Amazon account. Your receipt is sent straight to the app, and you can keep going. Amazon Go. No lines, no checkout. No, seriously.
Okay, so many applications areas are covered in these two videos. My voice is audible? Yes, my voice is audible. Okay, so we have seen these two videos and many applications areas are also covered. If you observed that if the refrigerator door is open, immediately you are getting the notifications. Okay, so how this is possible? So everything are connected. Okay, and this is one example that in that video we have seen the smart home, smart office, smart agricultures, everything we have seen. Again, in another video we have seen the smart shopping. Okay, so if you have your phone only, you can if you have no monies, if you have no cards, directly you can enter into the mall, you can purchase the whatever you want to purchase, no need to wait into the queues, long queues. You can remove from the malls. Okay, and billing will be automatically deducted from your wallet. Okay, so these are the various things that we can use if we want to use by using these IoT technologies. But independently, if we are using this IoT, then it has no meanings. Okay, combinedly IoT with cloud computing, combinedly IoT with big data, combine IoT with machine learnings will give you the more benefits. Okay, so now we will start the second part. Okay, already we discussed lots of theory in this first half. Okay, now all students are interested to do the hands-on. Okay, and as this is through online modes, this workshop is conducted through online modes. We will do the hands-on on simulations. If it was conducted through offline mode, you will get the more benefit, but still have alternatives. There are many simulations tools available like Proteus, like Tinkercad. So you can do all these things same as you are doing physically. Okay, so now you need to do all these things with me parallelly in your computer or your laptop, whatever you have. So you will get the benefit and you will understand how we can write the code, how we can do the interface, how we can execute the program. Okay, so what is Arduino is one microcontroller that we all knows, and I think some of the students might have used this controller also during their projects works. Okay, so there are many microcontroller, but we will see this Arduino microcontroller first, and whenever we have another sessions at that time we will see the different controllers. So Arduino has three meanings. First, the first is Arduino hardware that we are seeing in this diagram. Okay, so this is nothing, this is Arduino hardware. Second is Arduino software. So it is freely available open source software. Just write arduino.cc and you will get the software on your computer. It is freely available. Okay, and the third thing is Arduino open forum. Arduino open forum or Arduino community. Okay, so there are three meanings of Arduino hardware, Arduino software, and Arduino open forum. Okay, so in this microcontroller you can see there are 13 digital pins are there, GPIO we can say. Okay, so 13 digital pins are there, 0 to 14 we can say 14 digital pins are there, and 6 analog pins are there. So we have two types of sensor, digital sensor and analog sensor. So whenever you want to connect analog sensor, you can connect with this pin from A0 to A5. Okay, and if you want to connect any digital sensors, you can connect through these pins 0 to 13. So if you want to connect a temperature sensor, so temperature sensor is one type of analog sensor because it has many ambient conditions. Okay, it has one range. If we are talking about digital sensors, so it has only binary values, either 0 or 1. The best example is motion sensor. Okay, if the motion is there, the light will be on. If the motion is not there, the light will be off. Okay, so this is the example of digital and analog sensor difference. So whenever digital sensor we are going to use, we are not writing any conversion, but whenever we are going to use analog sensor, At that time, we need to convert the value from this collected high volt, means connected voltage, okay, current reference, and we need to do the conversions. And after applying the conversions, we have the temperature in Celsius or in Fahrenheit. So we need to do the code according to Celsius or Fahrenheit. If best example, again, the another example is ultrasonic sensor. If we are going to use ultrasonic sensor, then again it have many range, it has one range. So at that time also we need to connect that sensor with these analog pins, and we are measuring the distance from the object. Okay, what is the distance of this object from these locations, particular locations. But if we are connecting motion sensors, it has only two values, either 1 or 0. If we are connecting Bluetooth, it has only two values, it either 1 or 0. So we can say these are the digital sensor example, and temperature sensor is the example of analog sensor. It has 5 volt, it has ground. So if you are only connecting the LED or any small LED, if you want to blink the LED, you will connect one long pin onto the pin number, any pin number you can connect, and you need to connect the negative pin onto the ground. You can connect the positive. We have two values, plus and minus. Okay, so we will connect our plus value onto any pin, but if you want to connect the minus value, then you must connect that minus value at the ground level. Okay, we will see the example, so we will understand how we can interface the things with this Arduino, and how we can use the simulation tool also. So this is the detailed diagram of Arduino Uno. So whenever you are writing the codes, or if you have downloaded Arduino software through the open source platform, that is arduino.cc, you can see, if you will open that, and if you will going to click on new file, you have these two inbuilt command, two inbuilt functions are there. The first is void setup and the second is void loop. The first is void setup and the second is void loop. Okay, so in void setup, you can write the code that you want to execute only one time. Okay, so whatever command you will write, or whatever instruction you will write in the setup portions, that will execute only once. But whatever you will write in the loop in these portions, so that will execute repeatedly. So suppose you want to blink the LED on and off. Okay, so you need to write that command, on and off command, high and low command, or 1-0 command into this loop. So every time your LED will be on, after few seconds it will be off, after few seconds it will be on, after few seconds it will be again off, on and off. Okay, so continuously whatever you will write, whatever instruction you will write in these functions, that will be repeatedly executed. Okay, and in setup you need to write the code that will be executed only once. Now we can start the simulations, and before starting the simulation, you can see how we can execute, or how we can write the code in Arduino first. Okay, so if you have Arduino with you, if you have downloaded, if you students have downloaded from the open source, just open it. Okay, so you need to click on new file. Okay, and as we discussed, you can see over here, there is void setup and void loop, two inbuilt functions you can see. Okay, if you will open the file, you will see two inbuilt functions, that is void setup and void loop. Okay, so whatever we are writing the sketch over here. Okay, and that is our C code. So that you need to write over here. So all students are familiar with the C programming, so it will not be difficult task for you. Okay, so you can write your code over here. Now in void setup, which command you can write, that will execute only once. So suppose you want to blink an LED. Suppose you want to blink an LED. So you need to write the code over here. Okay, so in void setup, you will write the code that will execute only once. So you can see here, if you want to blink the LED, what you can write? You need to write the pin mode functions. Okay, so pin mode is the functions which have two modes, input and output. Input mode and output mode. So at which pin you want your output, or from which pin you want to read the data, that pin number you need to write over here. So suppose you want to connect your LED on 12 number pin, then you need to write pin mode 12, comma. What you want to do over there, at 12 pin you want output. So you need to write output over there. Okay, so these things you need to write only once. A 12 number pin, we want to connect our LED and we want to glow that LED. So what you need to write, pin mode 12 comma output, because we want output over there. Okay, and this is a case sensitive. So if you will write a capital P, it will shows the error. Okay, whenever you will verify your code, it will shows the error. But if you will write small p, it will be okay. Again in loop, what you can write, digital write. So when you want to turn on the fan, what you are doing, you are pressing the switch. Okay, and you are pressing on buttons. Again, if you want to off that fan, you are pressing the switch, the same switch. Okay, and you are pressing to the off mode. So like on and off, in Arduino we have high and low, two commands, high and low, but that things you need to write in this digital write line. Okay, digital write functions. So how you can write, our LED is collected on 12 number pins, so we need to write digital write 12 comma high, because we want to glow that LED onto the 12 number pin. So what will happen, that at 12 number pin the power supply will be provided and our LED will be on. But what you need to do, after some time, if you want to turn off that LED, what you can write, you need to write one more line, that is delay Okay, so after sometimes your LED will be on till 1 second. This is 1000 milliseconds. Okay, so for 1 second your LED will be in high mode. That means it will be on. But if you are writing the same line,
hello, hi madam, good morning.
Digital write 12 comma low. So after 1 second, whenever this instruction will be executed, your LED will be off. For which time? For 1 second again. Okay. So for 1 second it will be on, for 1 second it will be off. So this code you need to write for turning on and off your LED. Okay, if you have connected it onto the pin number 12 of Arduino. Okay, so if you are connecting on 13, if you are connecting on 10, then in pin mode and in digital write, you need to write that pin number only. Okay, so now this is the sketch or programs that you can write on open source platform Arduino. Okay, but if you want to use the simulations, if you have your hardware, you can write the code on Arduino. You can attach your hardware with your USB cable. Okay, and you need to press on this upload button. Whenever you will upload the code, your code will be uploading into the flash memory of that Arduino, into the flash memory of Arduino. Okay, but if you want to verify, you can click on verify.
Hello. Mali jo hai.
Okay, you can show your you can save your sketch in Arduino folder. You can rename whatever name you want to give, and you can save like this. Okay, and now it will shows if this code has error or not. Whenever you will click on verify buttons, it will shows yes, it has the error. Why it shows the error? Because your semicolon is missing. Okay. So right now you don't have any hardware students. Okay. So you need to use the simulations tool. So now we will see the same code on simulation tool. First, we will connect the LED first with the Arduino and how we can interface and how we can execute the code. So you will see and you will feel that physically we are connecting our LED with our device. Okay. Yes, done compiling status is there. You can see. Okay. So there is no error in this program, and you can successfully upload your code. If you have hardware device, you can attach with your laptop or computer. Okay, and now you need to upload the code. So what will happen? Your written code, your software, this is your software, I think. Okay, and your hardware is nothing but your microcontroller, that is Arduino Uno. Okay, so you are going to upload your code from this software Arduino, and you are going to upload the code onto the flash memory of Arduino Uno, that is on microcontroller. So that is nothing but embedded system. Okay. So now we will see on simulations, means how we can execute the code on simulations. So Tinkercad is the simulation tool. All students can parallelly do the task, so you can able to understand how we can execute or how we can interface various sensors and how we can execute the programs. Okay. So you need to open on this tinkercad.com. Whenever you will open it for the first time, it will ask you whether you are an educator, whether you are a student. So you need to click on students, then go next. It will ask you about your mail ID and passwords. If you have your existing Gmail ID opens, just you can select your existing email ID, and you have this type of board. Okay, and now after that you need to click on circuits. You need to click on circuits. Okay, so there are so after clicking on circuits, you can click on create a new circuit. Create new circuit. So what will happen? Circuit design window will be open. Circuit design window will be open. So you can see over here your Arduino Uno board is there. Okay, Arduino Uno board is there. So what you can do, you can select that. We have selected 2. Okay, so this is your Arduino board. You can see. Okay, as many students have no hardware, but you can use this simulations tools and you can understand how physically we can connect the same things, the same code we need to write, the same things we need to collect. Okay, and in online mode we can try with the simulations, and the same code will help you if you want to execute the same code at home. And if you have your device ready, just connect with your laptop, computers, whatever you have, and you can execute or you can understand how we can attach the various sensors with this microcontroller. Okay, now if you want to connect the LED, okay, then you need to select the LED from these components. You can see over here there is one LED. So on basic, you have the different components. Resistors are there, buttons are there, potentiometers are there, LEDs are there. Okay, vibration motors are there, DC motor are there. So you can try various things. You can see ultrasonic sensors is there, piezometer is there, temperature sensor is there, PIR sensor is there. Okay, so lots of things are inbuilt available in these simulations tools. Okay, if you have all these things physically in your hand, you can do the same thing, same diagram, same device, same connections, and same code also. Okay, so now we are connecting one LED. You can see just drag and drop concepts are there. You need to connect one pin on ground and one pin on pin number, any pin number, either 13 or 12. Okay, so this is how we can connect the LED. The long pin is connected onto the ground and the second is connected onto the pin number. Okay, and now you need to write the code. Now you need to write the code. Okay, so how you can write? You need to select the text. Already it is written, so you can see. Okay, here in pin mode, LED built-in command is written. Okay, LED built-in command is written. So if you are not writing pin number, okay, if you are not writing pin number, then 13 number is by default, it is LED built-in pin number. Okay, if you want to write the pin number, you can write 13 comma output, means at 13 pins we want output, at 13 pin we want output. Okay, in loop what is written? Digital write 13 number comma high. Okay, instead of 13 it is written LED built-in, because by default 13 number is built-in pin. Okay, digital write LED built-in comma low, means for 1 second your LED will be on, for 1 second it will be off. Okay, so now we need to start the simulations, so we can click on start. You can see, okay, you can see over here your LED is turning on and off for 1 second. So if you have physical hardware with you, you can do the same thing. No need to do any extra thing. Same way you can connect the LED like this. Okay, you need to connect your USB into your laptop's USB port. You need to write the same code on Arduino.cc platform, means Arduino software that you have, okay, or you have downloaded. So you need to click on new file. You need to write the same code and you need to click on upload. After writing the code, you need to click on upload button. Already I told you students, this is upload button and this is verify button. Verify button just says there whether any error is there or not, but whenever you will click on upload, your code will be uploaded into the flash memory of your Arduino or any microcontroller flash memory. Okay, and after that, if you will remove that Arduino microcontroller and at any place, if you will move to any place and if you will just provide the power supply, the same code will be run repeatedly. Okay, same code will be run repeatedly, just you need to provide the power supply. Okay, so this is your basic code. You can try in your Tinkercad account. Just open it, tinkercad.com, create the accounts, just select the Arduino board just connect the LED, just write this same code. Okay, if you want to change this code, and if you want, instead of 1 second, first you need to stop the simulations if you want to change the code. So if you want to increase the delay, means for 5 seconds if you want to turn your LED on, and for 1 second if you want to turn off your LED, then you need to change the code. Again, we need to start the simulations. So you can see for 5 seconds your LED will be on. 1, 2, 3, 4, and 5. So after 5 it will be off, and but off will be for 1 second only. So you can see the difference. Okay, if you want to increase the off time also, again you need to stop the simulations and you need to increase this delay. So for 5 seconds it will be on, and for 5 seconds it will be off. Okay, so this is the first basic code that you can execute, as this is not in offline mode, but in online mode also we can do the same things that we can do in offline mode. So all students, please try onto the Thinkercad. Okay, on Thinkercad, just open it, thinkercad.com, create your student account, just use your existing email ID and password and open it. Select the Arduino microcontroller, select one LED, just connect like this. Okay, and just write the code by clicking on this code button. Okay, now again I am stopping this simulation. Okay, so you can select any things that you want to connect with the microcontroller, then you can write or you can edit your code from this code window. Okay, so your whatever command you are writing or whatever code you are writing, that will be saved in your profile. Okay, so no need to worry what will happen if anything's happen. If your internet is off, again your code is there, it is saved in your profile. Again I am going to execute the same things. What to do? You need to click on Tinkercad. Click on circuits. Okay, lastly we execute this code, so you can see it is over here. So whatever code you will try, that will be in your account. Okay, in your profile it will be saved. Okay, so now if you want to attach the temperature sensor, or if you want to attach the PIR sensor, okay, you can attach the same things are there. Okay, in PIR sensor there are 3 pins. You can see there are 3 pin in PIR sensor, motion sensor. Okay, PIR means motion sensor. So the first pin, you can see there are 3 pin, 1, 2, and 3. Okay, 3 pins are there. So the pin number 1, you need to connect on the pin number 2. Why? Because this is a digital sensor. This is a digital sensor. So we need to connect on any digital pin. Not only 2, you can connect on 13, you can connect on 12, 11, 12. Any pin you can connect, but it should be digital pin. It should be a digital pin. because this is a digital sensor. Okay, so it has only two value. We can say it is a binary sensor. It has only one and it has only zero. Only two values are there. It has no range like temperature sensor. In temperature sensor, we have a range of value. But in motion sensors, we don't have any range of value. We have only two values, either one or zero. Okay, so in motion sensor, if you will see, there are three pins. The first pin is nothing but we need to digitally read the values from this pin number 2. Okay, the middle pin is nothing, it is the 5 volt or our power supply. Okay, so we need to connect that pin onto the 5 volt, and the last pin is nothing, it is negative pin, so that we need to connect onto the ground. Okay, so three pins are there in any motion sensors. Three pins are there in any motion sensors. And if you want to connect, students, what you need to do, you need to select Arduino, you need to select PIR sensor, just connect. No need to select breadboard. Okay, here the breadboard is also selected, but no need to select this white breadboard. Directly you can select your PIR, drag and drop your PIR. Just connect pin number 1 into 2 number pin, middle pin into the 5 volt, and the last pin into the ground. Okay, only this connection you need to do. Here register is also used, no need to connect. Okay, again LED, if you want to use LED, means whenever the motion is there, what you need to do, the light will be on. Whenever motion is not there, the light will be off, as we have seen in the video. Okay, whenever person is entering into the room, the lights and all the things are automatically turn on, and whenever the person is leaving the room, then automatically lights will be off. So this is due to whenever we are entering into the mall, the doors are automatically open. So this is because of this PIR sensor. PIR sensor, that is passive infrared sensor. Passive infrared sensor. So have you connected? Okay. Now what we need to do, we need to start the simulations because the code is written over here. Okay, and in code you will see the digital read command. Okay, so what is the meaning of digital read? Because we want to read the value, either at pin number 2 the value is 1 or 0, at pin number 2 the value is 1 or 0, so we want to read that pin value. Okay, that's why we have connected this pin on pin number 2, and we want to read the pin value, whether it is high or low, whether it is 1 or 0. If it is 1, means motion is there. So what we need to do, we want to turn the LED on. If the motion is not there, if the value is 0,
Hello.
then LED will be off.
Hello.
Okay. So this is PIR sensor, and now you can click on code. The code is simple. Okay, there are two pin mode functions over here in setup. So one for LED and one for motion sensor. You can see. Okay, so we have connected the PIR sensor pin number 2 onto the digital pin number 2. So what we want, we don't want any output from this pin, we want input from this pin. That's why the mode is input. Okay, so as we discussed in pin mode, there are two mode, either input or output. We want to glow the LED, so you can see the LED 1 pin is connected. LED 1 pin is connected on pin number 3. But at pin number 3, what we want? We want to glow this LED. So we need to write the output mode. We need to write the output mode. Here we want to read the value, either it is 1 or 0. So we can say it is input. And here we want to glow the LED. So we can write the output mode. Okay. So in code, you can see there are two modes, input and output. Because from this pin, we want to read the value, either it is 1 or 0, whether motion is there or not. And from this pin, light switch, we want to turn on and off the LED. Light switch, same as switch. Okay. And in void loop, students, you can see over here, digital write. Okay. So digital write is same like a switch. If you want to turn on your fan, you are pressing the on switch. So same way, first we need to write digital write 3. 3 is nothing but the pin of your LED, pin of your LED. So initially it is low. Initially it is off, we can say. Your LED is initially off. Okay. This is one variable, integer read. You can use any variable. Okay. So what is stored in this variable? The value that is read by this command. Digital read is one function that will read the value from this pin number 2. Okay. So you can see in setup mode, pin number 2 is nothing. It is input. It taking the value from this pin. Either it is high or low. Either it is 1 or 0. Okay. So whatever value will be there, that will be stored in this read variable. Now we are writing the if conditions. If the value is high, whatever value that we are fetching from this command, if any motion is there, then the value will be high. If the motion is not there, then the value will be low. So if the value will be high, then and only then we need to write, or we need to turn on the LED. So we need to write digital write 3, high. So means pin number 3 that we connected with the LED, that will be glow. High means on, low means off. Okay. So for particular second, it will be on. For particular second, it will be on. So you can see, if you want to execute this code, we need to press on start simulations again. Simulation is started. Okay. It has one range. Okay. So in that range, you can see the LED is on. LED is on. If the motion is there, whenever the motion will be there, LED will be on for particular seconds that we have written only 1 second. Okay. So you can see when the motion is there, LED will be on for 1 second. Now the motion is not there, so LED is off. Again, if you will do the motion, LED will be on for 1 second. So whenever we have any object, okay, then at that time your LED will be continuously on. If the motion is not there, if it is steady, the object is steady, then your LED will be off. So you can use this sensor for the security reason also at home. Okay, now we can stop the simulations. Again, open the code. If you want to increase the size of the time period of the lights, you can increase from this delay. Okay, instead of 1000, right, 5000. So for that particular time, after detecting the motions, the LED will be on for 5 seconds. Okay, again start simulation. Okay, so if the motion is there for 5 seconds, the LED will be on. Okay, and after 5 seconds, the LED will be off. So if you have your microcontroller ready, means physically, you can do the same connection. You can write the same code. Okay, so don't feel that this workshop is not in offline mode. So how we will learn? You can do the same things at home also. if you have your microcontroller, if you have your motion sensor, if you have LED, you can do the same things. Okay, the same code you need to write and same connection you need to do.
Hello.
Okay, so don't feel that this workshop is in online mode, so we will not learn anything. So you can do the same things at your home also. Okay, so stop simulations. Sure. If you will click on, instead of basic, if you will select your started and if you will click on Arduino, you can see there are many inbuilt things are there over here into this right panel. Into this right panel, okay. If you don't want to write the code, okay, don't be worried. The beautiful part of this simulation tool is no need to remember the code. Okay, just delete this. Okay, now if you want to use this push button, okay, push button, just click, just select on the button. What will happen? You can see. Okay, so one push button is attached. What is the importance of buttons? This will work like a switch, on and off, on and off. Whenever you will press it, your LED will be on. Whenever you will press release it, it will be off. So what you need to do, you need to connect one LED again. So from basic, you can select the LED. You can see, let me zoom. Okay, now we have two pins. One pin we can connect on ground, and one pin we can connect on any pin number. Let me connect on 12. Okay, so in code we need to change the code. Instead of blocks, we need to select text. Continue. Yes, this is our code. Okay, but instead of LED built in, what we need to write? We need to write pin number 12. Okay, so at pin number 12 we want output. If you are writing LED built in, that means it is connected on pin number 13, but right now we have connected on pin number 12, so we need to change this code and we need to write pin mode 12 comma output. Means at pin number 12 we want output. At pin number 12 we want output. Okay, and what is this pin mode 2 comma input? That means you can see over here our one pin is connected in pin number 2. Okay, pin number 2. So this will read whether the high and low commands are received from this pin number 2 or not. So if the high voltage is given, the LED will be glow. If the low voltage is given, the LED will be off. So whenever we will press the button, this will read high value. Whenever we will release the button, this will read the low value. Okay, so in code you can see there are two pin mode, one for push button. Okay, and we are reading the value, either it is high or low from this pin number 2. Okay, and the mode is input. And another is LED that we have connected on pin number 12. Okay, so here pin mode 12 comma output is written because we want to glow that LED. So we required output. Here we are reading the value from this pin, so we required input. Okay, only there are two modes, input and output. Okay, no other modes are there, so don't be worried. Now, what is this? Digital read. Same as motion sensor, we are going to read the value from pin number 2. Okay, so digital pins are used. So in motion sensor also one line is written digital read pin comma 2. Okay, pin number 2. So that means we are reading whether value is 1 or 0, whether the value is high or low, that we are reading. Okay, and that value will be stored in this variable. This is a variable. Button state is nothing but it is one variable. Okay, so if button state is equal to high, means these pins are reading two value, either high or low. So if the value is high, what we need to do? Not LED built-in, but which pin? 12 number pin should be high. 12 number pin should be high. So pin number 12 will be high. Okay, if the button will read the value high, the pin value will be high. If the button will release, then pin number 12 will be low.
Hello.
Okay, so this is our code that we have written or that we have modified. Now what we need to do? We need to execute or we need to start the simulations. Just press on it. If you will press start simulations.
I can tell you.
Okay, now if you will press the button, you can see the LED is on. If you will release the button, the LED will be off. So try to understand, students, the digital pins, analog pin functions. What is happened? We have connected this pin onto the pin number 2 of this digital pin. So here this pin is reading the value, whether it is high or low, whether it is high or low.
Hello.
So whenever we are pressing the button, at that time it reads the value high from this pin number 2 and immediately sends the command to this LED at pin number 12. So at pin number 12 we are receiving the output from the code, you can see. So if this digital read pin number 2 will read the high value, what will happen? Digital write 12 comma high is written. That means 12 number pins will be on. 12 number pin will be on. So here it receives the voltage value or high command from this pin number 12 and this LED will be glow after receiving the command. Okay, so this is the best part, or we can say machine to machine communications. Okay, machine to machine communications. If you have connected a temperature sensor in your room, okay, and if temperature is high and if you have your AC or your fan in your home, okay, so what you want to do, you want to communicate that two things. One object is your AC, one is your temperature sensor. So whenever the temperature sensor receives the high temperature value, so if you have written if conditions, if the temperature is greater than 40 or 35, then what you want to do, you want to automate that your AC will be on. So if you attach your AC pin with this pin number like this LED, okay, a 12 number, so automatically if you are writing digital write 12 number pin should be high, so your AC will be on. Your AC will be on. So you can attach any things. You can attach your washing machine, you can attach your motors, you can attach your fan, lights, AC, many things you can attach. Okay, but this is button. Instead of button, if you want to attach temperature sensor, okay, if it detects the temperature, if very high temperatures are there, automatically your AC will be on. Okay, if you are attaching motion sensor, so in night, if any motion is detected, your light will be on. So whatever you are connected on to that pin number 12, and if you are writing digital write 12 comma high, but when it will be high? After reading that value from pin number 2, that is digital read, we have two values. So it from pin number 2, if you have attached the motion sensor and motion sensor is detecting any motion, at that time the value will be high. So if the value will be high, the LED will be glow, means light will be on. If you required any message, then you need to write the code for the message also. So you're on your phone, you will receive the message. On your email, you will receive the email that one object is detected outside of your home. Okay, so you can try these things also at home If you have your microcontroller, physical microcontroller with you, if you have no microcontroller, don't be worried. Just try on this simulation tool, the same code and same things you need to do. Means same wirings you need to attach with the physical microcontroller, same sensor we need to use, and same code we need to write. That you are writing in the online mode. Okay, so don't feel that we have no microcontroller with us. You can use this Tinkercad tool if you have no microcontroller with you. So you can connect many things, whatever things you want to connect. So what you need to do? You need to open the Tinkercad. Click on circuits. So you can see lastly we executed PIR sensor. Okay, so that will be executed. Now if you want to see ultrasonic sensor or temperature sensors, okay, so you can use that sensor also. This is analog sensor, so yes, let we try one analog sensor, so you can understand directly we cannot write digital read or analog read, but we need to write the code also. We need to write the conversion code also. Students, you can select the temperature sensors from the basic components. You can see in basic components here, lastly, this temperature sensor is available. Okay, so you can select from this and you can attach. Again, there are three pins. Again, there are three pins. So middle pins is your analog pin. Middle pin is your analog pin. You can see over here. The middle one is connected onto the analog pin number. Any pin number you can connect, either 0, 1, 2, 3, 4, or 5. Okay, there are 6 analog pins available. There are 6 analog pins available. So you can connect on any analog pins because this is an analog sensor. Okay, now we have not two value, only 1 and 0, like button and PIR sensor. In PIR sensor and in button, we have only two values, binary values, either high, low, either 1, 0. Okay, so if motion is there, we need to turn on the light. If the motion is not there, we need to turn off the light. Okay, so in temperature sensor, we have a range of value. Either it will be 39, 40, 45, 99, 100. So we have a range of value. So this is an analog sensor. This is one analog sensor example. Ultrasonic is also analog sensor. Okay, so let's see the code. Yes, we need to connect the middle pin on pin, any analog pin, and the first pin that you can connect onto the 5 volt. This is your voltage pin, power supply pin. Okay, and last pin you can connect onto the ground. This is your negative pin, so you can connect onto the ground. Okay, if you will not going to use, if you are not going to use breadboard, don't be worried. Directly you can connect middle pin to the A0, first pin onto the 5 volt, and last pin onto the ground. Don't be worried about this breadboard concept. Okay, just connect these three things in this pin, 3 pin. Okay, if you want to use one LED, just use one LED. Now you are knowing how to turn on the LED on and off. Means if the temperature is above 40, then the LED will be on. If you have your AC, if the temperature is 40, turn on your AC if it is connected with this pin. Okay, so you can see this code. So in setup pin mode, you need to write A0 comma input. A0 comma input. What is A0? A0 is your analog pin number. And why input? Because we want to read the various value from this pin number, which value you are receiving. Okay. So here what is happening in analog sensor, whatever voltage is there, we are receiving that voltage from this pin number and we are converting that voltage into any values, either Celsius, either Fahrenheit. Okay. So you can see over here, there is conversion over here. So whenever you are going to use analog sensor, at that time you need to write the conversion. Okay. Whenever you are going to use digital sensor, at that times just we have two values, so we are not writing any conversion. So try to understand the difference between analog sensor and digital sensor. In analog sensor, every time we need to write the conversion. In digital sensor, just digital read is enough, because digital read will only read either high or low, either 1 or 0. Okay, but in analog read we have various value, so this type of conversion is required. Okay, and this is 0 to 1, 0 to 3. So these are the values, voltage values. Okay, so if you want your data in Fahrenheit, if you want your data in Celsius, you need to write these conversions over here. Okay, so now we need to start these simulations. Zero Celsius is 0, Fahrenheit is 0 initially. 0 Celsius speaking. The baseline value is not read by this. Okay, so here baseline temperature is set to the 40 and initially the baseline is 0. Okay, so what is this? Whenever the temperature sensors will read the value, okay, so we are setting one value, means the baseline value is 40. Okay, so here one condition is written, you can see, if it is greater than that baseline temperature, if it is greater than that baseline temperature, then the LED will be on. So if you want to turn on your AC, okay, if you want to turn on your motor, if you want to turn on your fan, you can do, you can write that pin number, you need to connect that object with that pin number, okay, wire of that object with that pin number particularly, and then you can write, after detecting this, if this will be high, then digital write that pin number value should be high or that pin number value should be low. Okay, so now if you will click on start simulations, you can see over here. Okay, so if I will increase the temperature, you can see this, actually this was deleted, that's why it shows the error. Okay, but now you can see the blue LED is on, yellow LED is also on, and green LED is also on. But if it will be low, all these three LEDs going to be off. So if I will change the range of temperature, if it will be increase, and if it is beyond after above 40, then you can see green LED is on, blue LED is on, and your brown LEDs or yellow LED is also on. Again, if it is low, then all three LED will be off. You can see. So means if the temperature is high, you want to control, you want to send the signals to other machines or other objects, that if the temperature is high, then you want to turn on your AC on, you want to turn on your fan on. Okay, if you want to turn on your motor on, again, if you attach the ultrasonic sensor, so what is the task of ultrasonic sensor? It will detect the distance. Okay, so if you attach the ultrasonic sensor into your water tank, and if you want to do the automations, right now we want to press on the switch, then when we will press on the switch, the motor will be on. But if you want to do the automations, what you can do, just attach the temperature sensors with your motor, okay, with my microcontroller, and in your water tank, just place it, that ultrasonic sensor. It will detect the water level. What is the task of ultra sensor? It will detect the distance between the objects. Okay, so whenever that water level is very low, automatically it will send the signal to that pin number, that digital write this pin should be high if this is the level. So automatically your motor will be turned on. Okay, so Tinkercad is one simulation tool, and my today's goal is to explain you how we can execute the code on Tinkercad, how we can connect the various sensor or interface the various sensor with the Arduino Uno microcontroller. Okay, so you can try the various sensor also. You can connect many sensors. So in 2 hour times only these things is possible. Okay, whenever in future we will get the more time, we will see Node MCU and Raspberry Pi controller also, and we will see the protocol also. Means how we can store the data onto the cloud, and from cloud how we can process, how we can store the data on cloud, how we can process the data on cloud, and from that how we can remotely control the devices. Okay, so in future we will see that part also. So that's it from my side. Now if Arpit sir, any students have any query, they can ask, otherwise we can end the sessions.
Okay, sir. Am I audible, sir?
Yes.
Okay, sir. Thank you so much, sir, for sharing with us.
Welcome and thanks for inviting me. If students have any doubt, they can contact me on my mail ID
Okay, sir.
brijesh.wala@paralleluniversity.ac.
Okay, sir.
Thank you. May I leave?
Okay. Okay, sir. You may leave now.